Bioengineering is the intentional design and application of biology to solve real-world problems. At APL, bioengineering and biology is deeply mission-driven. We create the solutions that can operationalize biology to solve challenges for national security and for the government. One example is our work for bioattribution. Synthetic biology has truly enabled new types of biology so that we are able to create new therapeutics and we're able to create new vaccines. And we're able to use that for biomanufacturing where we're creating new materials that are useful out in the world. However, we also need to think about how to ensure that those same tools are not misused. And so here at APL, we've been developing tools so that we can understand how was an object made, where was it made, and we can understand if it's been intentionally modified or if it's a natural event.
Biomedical engineering is really applying the engineering principles to studying aspects of biology and medicine. I'm in the regenerative medicine space, and we're interested in replacing tissues and organs that have been lost due to trauma, some type of damage, congenital defect. Now we're actually looking at replacing tissues that have declined due to aging. So the field's evolved quite a lot over the years, and we're excited about the way it's moving. Not just replacing tissues, but maybe modulating and improving diseased tissues. Being an engineer allows you to really connect with lots of different fields, and now with new technologies that have developed, giving us big data, we're connecting with computational advances that are happening to help us design better therapies.
Bioengineering is not just biology, it's also chemistry, it's material science, it's physics, it's analytics. And so we can work across the entire lab to really ensure that the materials that we're developing are going to be applicable for a wide variety of application spaces.
Particularly working in medical and biological fields, the question really comes up of, well, what different perspective can engineering give? And the training in engineering, more quantitative thinking in systems, lets you ask questions like, well, why is this therapy not working? Let's think of all these systems factors that integrate to determine responses. So I think it's really an approach to thinking. Science is made to discover how things work, and engineers are trying to make things work, right? So a little bit of a different perspective.
Professional societies are extremely important for creating that technical rigor, the peer review capabilities, and a network of scientists that can collaborate and really drive a field forward. I received funding and support and the ability to attend conferences and really present my work as I was coming through my training. And so creating those types of communities really enhanced the ability to grow as a scientist.
Professional societies enable community members to come together, share data, talk about ideas, and really work together to see how we can move the field forward, how we can improve education, train the next generation, and where all the applications are. So it's really the mode for that to happen. I think it's important to remember the national academies are actually service organizations. We're there to provide a service to the government and advise in science and engineering policy. So we can have a big impact across multiple areas as a service to provide advice.
The work that we are establishing in bioengineering are really the foundational tools to enable the expansion of biotechnology into all of the different critical challenges that we see here at the lab and really start to solve those problems in new and novel ways that couldn't be done before.
When I think of the future, I often hope that it's beyond my dreams. I'd like to keep an open mind and not make too many predictions, but the pace of discovery continues to increase, and people and the science community and our communities more broadly are critical for that future and building that together.